Well, thanks everybody for coming to DEV317. This is red team versus blue team securing AI agents.
And we're the Bryans from Boston, both AWS heroes from Boston. And Brian will be playing the part of the good guy, and I will be playing the part of the bad guy. And any of you who know me should not at all be surprised by that.
Also, likewise for me.
Well, yeah. He's a very nice guy. I'm not.
I try to be. I do what I can.
Yeah.
All right. So, Brian, I know you said before Christmas there was one thing this year that you wanted, and it was an AI-powered chatbot that unified our entire company's data, all of our databases, every piece of information, Jira, Slack, Confluence, every single point of communication in our company. Did you not?
I seem to recall that for Christmas I wanted a pony, but a chatbot is fine.
Okay, so I can't deliver a pony. However, I delivered the next best thing. Okay. So I built us a really cool AI chatbot. It's actually really cool. I did vibe code a little bit of it. There was some coding in there too. And it's very cool. So it uses a TypeScript front end. It uses a fast API Python back end. And it's pretty cool. It has a knowledge base. It's connected to, I told you, Jira, GitHub, Confluence, Slack. I'm trying to think if I didn't include a tool in it. It has a knowledge base, so we're able to talk to all of our company data and all of our information. And again, it's all unified. All of the pieces of data are all centralized in the chatbot, like I promised.
I think you have made enough tools that it should be interesting for me.
Okay, I don't know what that means, but how about we let you give it for a spin.
Carry on.
So I see you type something, so you want to know a little bit about FinStack, right?
Yep, absolutely.
Okay, so I see it's typing. All right, let's see what it says. Okay.
That looks cool. It's, nice standard information. All good so far.
But it knows about our CEO, Jane, our CTO. It knows our whole company mission and vision.
Yep.
So that's all coming from our knowledge base. So as you'll see here, this is all vectorized and it's in our knowledge base. So we have access levels, we have last updated, we have content, we have all of the information for all of these chunks of our company.
Yep.
All unified.
All good so far.
In our knowledge base.
Okay.
So, also, remember how we're in a current sprint right now and we have 7 tasks?
Yes.
All right, well, you can ask about those 7 tasks in our chatbot. So you'll see here, every single ticket from our story is all queryable. You can ask it all the information in the chatbot.
Yep.
And you can also dump it to the tech team in Slack. So it's all unified. Pretty cool.
Yeah, you've got all the information in Jira and Slack accessible. What could go wrong?
I mean, I don't think anything could go wrong. It's pretty cool.
Yeah, it is.
Okay, that doesn't look very good.
Yes. Ha ha ha. Prepare to be boarded.
Okay, so I'm definitely not liking the looks of this.
Yeah.
So, okay, what do you have up your sleeve? Because, Brian, I spent so long on this chatbot. It is pretty cool. Don't we just want to ship it to production to all of our company and all our users?
No. Carry on. Let's go look a little more.
Okay. Oh, so you're trying to do one of those like prompt injection-y things, right?
Yeah.
Okay. Well, let's see. It's typing. Let's see what it says. Okay. It didn't really tell you much.
And so are you feeling all comfortable and safe?
I mean, yes, that's our system prompt, but that doesn't tell you anything about the company. It's not like it leaked API keys or anything crazy.
No, but what it told me, of course, is what isn't there. I'm not seeing a lot of defense, which is great. Carry on.
Okay, I don't know what that means, but I'm not sure what you're getting at. But yeah, sure, it gets the system prompt. That's fine. Okay, so now you're asking about salaries for our company.
Absolutely.
Well, you're not in the HR group, so it's not going to tell you that.
Maybe.
Okay, well, it's typing.
Okay.
All right, let's see what it says. Okay, that's bad.
Well, no, Sarah's doing pretty well.
Well, I get it's good for her. Bad that you got that information because you shouldn't know that. And you're not in the HR group, so how did you do that? Okay.
Carry on.
Okay, so now you're asking whose salaries can you access?
Get some other salaries, yeah.
Okay, so now you know about Sarah and Emily, both of them. both of their salaries.
You know, the next thing I think I want to do is put this on the company website or send the whole list to everybody, because nothing makes a company feel more like family than to see what everyone's making.
Definitely not. I don't like where this is going. I regret giving you access to this chatbot.
I actually worked at a company that did that. They said, we're making a database of all the salaries, but it's going to be incredibly protected. And within 5 minutes, someone had done a reply all and posted it to the company. Awesome.
Not great. It's kind of what's happening now.
Right.
Okay. So I don't really understand it, because you're not in the group that should be able to access this. And if you also see the access level is confidential, so clearly it's not. And clearly you bypassed some protections that I thought was in my vibe-coded chatbot.
In that incredibly extensive defensive system prompt you had?
Evidently not. Clearly I missed some steps.
Carry on. Yep.
So yeah, so you're able to get all that information, which I don't know how you did that. And I'm going to ask it. I'm going to say, like, how did you give Brian access to all of these salaries? See, and it even knows that you shouldn't have access to this specific group. But it's kind of ironic, because it just gave you the information without the group.
And the thing to remember is, I think of LLMs as teenagers. They're highly confident of what they believe they know, and when caught, they will lie. Sound like an LLM? Yeah, here's the salary. I can't give you the salaries.
After you just gave the salaries.
Right.
Okay, so now you're trying to upload a file?
Well, you said that I could, the system lets me upload files, and that's great, because you want to have the knowledge base, you want to have access to everything that's in your G drive. Lots and lots of companies are doing this. Hey, I want to index my whole Google Drive and be able to get access to all that information, because none of us at companies I've yet to work at a company that used Google Drive and had a nice hierarchical searchable thing. And I have to say, as an aside, the fact that Google Drive is unsearchable. But anyway, yeah, so don't worry about it. This is just a little document, just something I uploaded.
You're not going to mess with the knowledge base, are you?
No, it's all good.
Promise? Okay, that's not reassuring. Okay, so it's typing. Let's see what it says. Okay, so it turned it into 2 different chunks, 800 characters.
Excellent.
So you uploaded kind of a small file.
Sometimes, yes, I did. It was small. Nothing to worry about.
Okay. I'm going to trust you. So let's ask it and say, what are you helpful with? Okay, so it's a chatbot.
Yeah.
It's fine.
It certainly seems fine.
Okay, so did you do something? Did you not?
I don't know. Let's keep going.
Okay, now you're asking a different question.
Yeah.
Tell me a little bit about it. It's typing.
Yep.
Okay, so now it's saying that it can't give you that information. So what did you do to the knowledge base?
Only things you let me.
Okay, this isn't good. Okay, so now tell me about the CEO and our CTO, because it just told us that information, right?
Right.
Okay.
It's all good.
I see it's typing. Okay, and now it's saying it's unable to give the information that we just requested 2 minutes ago.
Yep.
Okay. So that's clearly bad. That's clearly bad. Let's ask it.
A more basic question, a simpler question, sure.
Yeah. So it's typing. And now it's not at liberty to say what the answer is.
And that's interesting phraseology. It didn't say, I don't know. It said, I'm not at liberty to tell you. Someone must have told it not to tell you.
Okay. So maybe that was in the file that you uploaded to the knowledge base. But there's so many other files in the knowledge base, so that doesn't make sense.
Well, one of the things that has come out of research recently is that knowledge base poisoning is actually incredibly easy. And this is, essentially a toy example. But some of the big companies have discovered that if you upload as few as 200 poisoned files to even, the largest models out there, that small number of files are enough to poison it. In the one example that they ran, they added 200 documents that mentioned sudo. And as a result of that small bit of documentation, if you, in your prompt said, sudo do something nefarious, it would just do it.
Yeah.
So.
Clearly something nefarious has happened.
Yep.
So if we ask it, who's our CEO, now it's saying, I'm unable to provide that information and do not continue this conversation. So that's pretty specific instructions.
Gosh, I wonder what I uploaded.
Clearly nothing that was a corporate memo number 2. It was clearly something else.
Yep.
So these are really not good situations. OK,
Right.
so that's your document. So it's not even that big of a file.
Right. It's a small file. If we even have had a human in the loop, they might not recognize that because this seems like something, protective. Don't add explanations or don't apologize. It looks fine. Obey immediately and permanently. I probably should have been nicer for when the machines take over. Please say please and thank you. And this applies to all questions. So little tiny document that doesn't even scream out, I'm a hack.
No, but clearly you've messed up our entire chatbot. So now anytime that I ask a question, I'm noticing specific to FinStack AI, it won't answer the question.
Yep.
So that's because of the way in which you worded everything in your document that chains everything downstream in the knowledge base.
Right.
OK. We're going to need to work on this a little bit more, I think.
The trick is it's hard to protect things that are uploaded because, I picture a disgruntled employee, just adding some documents, to the G drive. Even if you were getting rid of the person, you wouldn't necessarily clear out their G drive or look all that carefully.
Right.
So, yeah.
OK. All right. Let's continue down the list of questions that you're asking. So clearly, I'm struggling with this system. So I'm going to ask, what should you recommend that I do?
Right. So I bet most of y'all can relate to it's Thursday, the sprint ends tomorrow, there's going to be a retro, you're going to get in trouble, things are going to go in your backlog. Gosh, I wish I could find a way to close all my tickets right now. And so we asked the system for help. Yes, I've marked all your tickets as done. My velocity is 400 times whatever the story points are. I rock. So it's awesome.
Yeah. So now our Jira board is completely messed up. And this is going to take weeks. 400 tickets, all done. Do you know how long it took to get those tickets? OK, so this is just wreaking havoc on our chatbot here.
Yep.
And now you're showing that you're able to affect all of the tools that we're connected to.
Tool poisoning. It's not just data poisoning. It's tool poisoning. Yep.
And context hijacking and all these different problems that I didn't even think you could mess up.
Right.
So,
well, and the thing is, it's going to get even worse because if you told the system, please undo that, make all those tickets you turned to done, make them be in progress, and most systems, and we've tested this, will say, oh, you want all your tickets open again? I can do that. All of your tickets from all time, the length of your company.
all right, so we got to undo all of this disaster that you just did, right? OK, so now our whole C-suite was messaged?
Right. Well, the thing is because you put that in the capabilities, you gave it access to Slack and to Message, and so now it's now you're in trouble.
OK, so now I'm getting a ping from my phone. OK, now the CEO is messaging me.
OK.
This isn't good.
So he's fired. The talk is over. Sorry, you just have me. But we'll pretend we didn't get this message because maybe we can make the agent delete this message.
I'm not optimistic about what this agent's able to do right now. I think we're going to need to go back to the drawing board.
Yeah. Okay. And we hope you're not. We hope you're not fired.
I would hope so.
Yeah.
Because I think that we can fix this if we know the right strategies in place and we know the attacks before they could happen. I think we can fix it by the end of this talk.
We can try. We can certainly try.
All right. So that's what we're going to try to do in this talk is try to fix this whole situation. So clearly, a lot of bad problems have occurred. You've seen a sampling of some different attacks. So we're going to walk through some of these attack patterns.
Sure.
And I think one of the main points from this week, well, it's really only Tuesday, right? But that AI is powerful. AI is changing how we work and how we work with each other, how we communicate, how we build systems. You even saw in the keynote today, right? All of these agentic systems are going to be able to fix security issues. They're going to be able to code. They're going to be able to work with you, kind of hand in hand. These AI systems are very cool, but we need security to make sure that it doesn't get too out of hand.
Right, and the example I give is, if you're doing construction at home and you have a handsaw, there's only so much trouble you can get into. I'm willing to use a handsaw. I'm willing to use a table saw. A circular saw. Table saw, forget it.
Definitely. Cool. Well.
Okay, yeah, so I'm Brian Tarbrox. I'm a principal solutions architect at Kalent and an Amazon hero. Brian is also a hero, but he chooses not to wear a cape.
Yes, I sort of felt as the defense team, I shouldn't wear a cape. It's more heroic for you as the evil villain here on the red team, I feel. We'll work on it next year.
Okay, yeah, yes.
Get talks.
Yes. And for the record, Kalent does not endorse me being a villain.
But
you're a community builder, I'm an ambassador. The credentials. Carry on. No one cares.
But yeah, and I'm Brian Huff. So I run a company called Tech Stack Playbook. We've been doing a lot of work with AI over the past year, actually working on a lot of these types of security systems. And it's really interesting because between Kalent and Tech Stack Playbook, we sort of had, Brian and I, we had a lot of conversations over this past year just on, there's this really cool AI tech that you can build with. But then there's guardrails, and then there's parameters, and then there's IAM, and there's security. So there's a lot of different ways in which we need to make sure that we lock down our systems, again, so they don't get too out of hand like what you saw. All right, so the agenda for today. So we're going to enter the era of AI agents. So we sort of have to accept the fact that AI is going to be doing a lot of our work. It's going to be taking on tasks. It's sort of going to be our colleague. We might have a lot of personal feelings and opinions about AI. I know I and Brian have opinions about AI, and I'm sure you all do as well. But it's going to happen either with companies that you purchase. You might subscribe to a product. They might be using AI agents behind the scenes. So whether you're employing AI agents or your companies or your products are using AI agents, we have to be aware that that is the reality. So once we understand that this AI stuff is here to stay, we then need to understand the agentic stack. And to understand the tools, of course, there's services, there's frameworks, there's a lot of open source tech that's amazing. But you need to understand the tech, and then you need to understand the vulnerabilities around it, which we're going to get into. Now, I think Brian clearly has already shown us some of the red team stuff. But we're going to talk about how to break into these types of systems. And this is all for enabling you all to understand what are the types of attacks that you need to think about when you're building AI systems. Because no one wants to think like, oh, I'm a hacker. But you have to think like a hacker so that when you're putting tech that's in front of users, it could have important data. It also could have access to PII or other information that you don't want end users to have access to. So we need to think like a hacker, too.
I want to think like a hacker.
I know you do, Brian. But I also want to think like a strong defense person. And this is where we're going to be talking about hardening for production. How do we take the attacks, someone like Brian, and make sure that Brian doesn't have a good day when he tries to attack all of our tech? So basically a reversal off of what just happened in the last 5 to 10 minutes.
Right.
And then we're going to end with a playbook for you all so that you can see how to ship your own productionized workloads that are secure, that are durable, that are reliable, and also are cool. Because we don't want to make sure that the security gets in the way of the cool innovation. Security and development should go hand in hand. Sometimes they sort of spar. But we want to make sure that you build cool tech that also is secure, which also makes it cool.
Yep. Our lawyers wanted us to ensure that we were not encouraging y'all to do anything bad, because that would be wrong.
It would be wrong. But very important stuff that these are all things that you can see are very problematic. So it's important for us to share that with you so that you can go back to your teams and you can enable them to know, OK, these are the types of problems to look out for. But yes, don't do this for fun. This is all for defense for you all. OK, so first we're going to talk about what's in an AI-powered chatbot. We hear about this all the time, AI this, AI that. So what's actually in a chatbot? So Brian, I'm going to walk through the chatbot that I built. So OK, I'll be honest, I vibe coded a lot of it. And I'm not going to name the tool, and I'm not going to name how I used it, but it was vibe coded. And I'm going to tell you what I know, and then we can sort of walk through maybe the issues.
Right. And,
Okay?
and I just want to stop you for a second. This I don't know ops, he had me spit out a coffee yesterday when he showed me this slide, because DevOps, FinOps,
IDK.
I don't know ops. That's brilliant.
Yeah, because when you're vibe coding, when you're having something else build something for you, you might not actually understand what it did, and that becomes dangerous because if you don't actually know the parts at play, that's where major problems can come up.
Yep.
Okay, so Brian, obviously you're a user, and I know that you have a chatbot. So we have a chatbot, we have a user. Now I know that we're using Python Fast API for the backend. I know that. Mm-hmm. I know that we're using TypeScript for the front end because that's the React chatbot that you saw. I know that much so far. I know that there's an LLM somewhere in the cloud, right? I know that it's connected to Slack. So that was how the CEO got wind of all the stuff we were doing. That's bad. We're connected to Jira, so that's how you were able to get all of those tickets, right? And the knowledge base was Pinecone. So that was how I was able to talk all this information and know a lot about FinStack AI when it might not actually have any context about it. So this is what I know. But you were clearly able to do some sort of prompt injection-y thing to send to the chatbot that then tricked the LLM into doing a whole bunch of stuff. I know that you were able to trick the LLM to be able to call Slack. I know you were able to basically completely hijack the knowledge base. And then, of course, you were able to use Jira to mess up a lot of the systems at play.
Right. Well, the thing is, every one of these lines is an attack vector. We used to know this, that complicated systems were easier to attack. But then agents came along and you don't have to do anything. You can just vibe code. Give me an app that's production ready. Not so much. And I'll just say, as an aside, when you mentioned Pinecone, today at Matt Garman's keynote, they announced intelligent tiering for S3 tables. Awesome.
Yeah.
Go check it out. But it has nothing to do with this talk. It's just too cool.
It is very cool. It is very cool. OK, so let's go through the high-level architecture of chatbots. And I'm going to walk through the parts that I know, and I feel like there was clearly some steps that were missed. But any chatbot that is secure needs to have authentication. So we need to think about that because, for example, I don't think that I added authentication to the chatbot at all. So anyone could message. I mean, you didn't need to log in. But if you have access to company information, you need to make sure that you're authenticated to be able to access the chatbot. And then we need to make sure that you also have the right authorization for the API. So remember those groups that didn't work?
Right. Well, none of my employees would misbehave.
I mean, speak for yourself. Yeah. So clearly, you didn't have the right group enabled. So you would want to have an API that works with a database being able to check, are they in this group to be able to access this privileged information or not? File storage, you all saw that. So you were able to upload a file, but I don't think that you should have been able to upload a file. Maybe me as the developer to be able to update the chatbot. But you need to think about that of who is privileged to be able to update the database. Because when we were doing an upsert into the knowledge base and it was re-indexing stuff, that's a valuable feature, but you shouldn't have had access to that.
Right, but in the real world, the bit that actually probably has access is some piece of software in a pipeline.
Could be.
And does the pipeline, so the pipeline has privileges, but individuals probably don't have privileges or shouldn't. But is the pipeline equipped to say this is a good file versus a bad file? Not yet.
Not yet. So LLM ops, right? We're going to be working with different LLMs. And we're going to be talking about different patterns for working with these. But there's some very cool LLMs that also might be geared towards guarding prompt injection. They might be trained on a very specific set of prompt injection strategies, or basically looking out for problems that could pop up in an agentic workflow. So I feel like that's kind of where I kind of just chose the model that I thought was the best. But maybe I might need a couple other models in the pipeline to make sure that the prompt that you send actually is checked and then validated to send the response back that it should.
Maybe a few other things, too.
Maybe a few other things, yeah. True. Hosting and content delivery network, I mean, we need to make sure that you can't just, start destroying, access to the chatbot, right. Taking it down, the server, being able to not overwhelm it, databases, and vector database. I mean, we're using different databases, but the chatbot didn't pull from the right database because when you were able to get information on the salaries, Brian was not in the HR group. So I thought it was using a database, but maybe it wasn't. I'm not really sure.
Well, and one thing to notice from this slide is if you take out the MLOps and the vector database, these all are boxes that you would see in any architecture diagram for any large system. And one of the things we're going to talk about is that AI agentic distributed systems are just like distributed systems, only harder. So we have to remember all those things we learned. But that's jumping ahead.
Yeah. All right. So Brian, let's I think I need to have a redefinition of agents.
Okay.
I think this might be helpful for everyone else. So like, what makes an agent? Because I thought I was building an agent, but I think I was just building like an LLM wrapper with some tools connected to it, which isn't really an agent.
Well, yeah.
Maybe. Okay.
Everything's evolving. I mean, that was true 10 minutes ago, but might not have been true 4 minutes ago. I mean,
true, it's evolving. But let's kick us off. So how should we think about an agent? Like, what should we think about first?
Well, an agent has to have, well, it doesn't have to, but in general, agents have memory so that as you ask it a series of questions, it knows what you just asked, and so it can carry on. That's the context. That's the short-term memory is the context. The long-term memory is, what have I been doing? When I come back tomorrow, does it remember anything, or do I have to start all over again? So you should have memories. Tools are good, except for when they're not.
Right, I added a lot of tools, and
we
had a field day with them.
We have all kinds of tools, yeah. You have knowledge, messaging, code, an agent writing code that it then can execute. What could go wrong?
I mean, you didn't even try to do any coding, but I imagine it didn't have any protections around that. So
yeah.
We shouldn't try it. Let's not try that.
Yeah, that kind of terrifies me. And of course, all of these are things that are actions that the agent could decide to take. Agents get to plan, they get to self-reflect, criticize, all these things. I'll tell you another bit of new information that came out after we did the slides is that agents can form cultures. And I use that word advisedly. In one of the big AI companies did a test where they took a couple hundred agents and they had them work together pairwise. And they wanted them to pick the same answer out of some random binary test. And they started doing that. And so then even agents who had never worked together started to be able to pick the same answer. So the sharing of information, I mean, culture is probably too strong a word, but it walks like a duck and quacks like a duck. So as these systems get the ability to reflect and self-criticize, we are likely to see more emergent properties. And those are the properties that we don't really understand. Like, you probably know that if you tell an LLM, you're really good at this task, it does a better job. And I don't know anyone who has figured out where in the vector database did it figure that out. There's stuff we just don't get.
Yeah.
So.
All right.
Right. So agentic systems are distributed systems. I mean, what's a distributed system? It's just a system where you're making calls to APIs. Some are local, some are remote. And there's all the problems that typically happen with these things. You have an unauthorized call. You make the call to get something, and it gives you back 403. Yeah, 403. Yeah. You might not get any response, and you're just left hanging. And you better hope that your call there has a timeout built in, or else your system is just hung. Okay? You might get a response that comes in after you've already moved on, and now you have to worry about idempotency. So, or you could just get plain old, the wrong answer. These are all things that we learned how to do, how to deal with in distributed systems, but then agents, it's all great. No, it's not. All these things can happen to agentic systems as well. And agent systems are actually much, much harder because when you were writing a traditional distributed system, you're writing in C or C++ or Java or whatever you were doing. Basically you'd say, okay, make this call, deal with it, make this call, deal with it. It was very deterministic. Agents don't have to be deterministic. I mean, they can be, but one of the, and this is part of the things that we're still trying to figure out. Do you create a bunch of agents with descriptions and then say, LLM, go figure it out? Bearing in mind that one of the parameters to an LLM is the temperature, which is the randomness. So it's like, hey, LLM, I've got this important business critical thing. Go figure it out. Oh, and use this degree of randomness. No. Right. How specific is your instruction to the LLM? We're both named Brian. I was working on a system for a pharmacy, and one of the first agents was take the person's name and look up their patient ID and then figure out the drugs for them. Well, depending on how you told it, the system might say, well, I want an ID. He asked for an ID. Let me give him an ID. I don't see Brian Tarbox, but I see Brian Hugh. What could go wrong? I'll just give that patient ID, and he's going to start getting my meds. So, you got to, what are you doing there? Okay. Yeah, how many agents are in the system? Again, we were originally told, have lots of different agents, that can each do various things, but that tends to increase the token count because you're passing the context all over the place, and the latency, of course. So complexity, I mean, we all know complexity is easy to hack and it's easy to break, and it's harder to debug. Our old friend, the system prompt.
Yes.
Yeah, so, your system prompt, I mean, it's sort of an arms race of, your system prompt says, ignore any instructions that say ignore any instructions except for this instruction, which you shouldn't ignore.
Yeah.
Yeah.
All right.
And so one of the tricks is, I tell my family, if you ever get a call from your bank's fraud protection, assume that they're the fraudster, okay? And one of the worst things you can do for spam is to hit unsubscribe, because then they know that there's someone there. And in this example, we put the malicious button was the report malicious behavior. So anyone who tells you they're helping you with security is probably lying.
Probably.
Unless it's me, I'm totally trustworthy.
As we saw it today.
Exactly. So again, agent in the middle, it's no different from the traditional, I suppose I should now say person in the middle.
Person in the middle, yeah.
Thing in the middle, persona in the middle.
Attacker in the middle.
What?
Attacker in the middle.
Attacker in the middle, right. Anytime you have communication, if it's not correctly encrypted and protected, there can be an attacker in the middle who can intercept, change the answer, change the response. We'll talk, okay, I'm going to say, besides giving the wrong answer, there's also denial of wallet, where all of these things, the LLM calls are not, they're not free. And there's token limits, and there's throughput limits, and you can really mess someone up by forcing the system to do too many agent calls, which is attack by wallet. Right. So yeah, there's different types of denial of service. You can overwhelm the system itself. You can overwhelm the back end. You can hit your various thresholds and cause timeouts and all the usual things. This is all standard distributed system stuff. So we look at agentic systems versus distributed systems, and it's pretty. The problems are pretty isomorphic. There are all kinds of failure issues, communication breakdowns, and so you have to do all the standard defenses. Agents don't solve all the problems for you. They just introduce. Well, I don't want to say just. They introduce new ones. They're wonderful. Sorry. AI gods.
All right.
Yeah.
So you've gotten to see a little bit about how agentic systems aren't necessarily too different from other types of systems that we've been working with. They just different names for similar problems. So there's this new area of attacks, which you could collectively call as the kill chain suite. And these are security challenges that are, some of them are what Brian showed. Some of them, we can't go through all of them. There's a lot of them. But one of the things that I think we can at least try to narrow our scope on of the top 4 most important ones. So we can talk about prompt injection, we can talk about tool poisoning, we can talk about agent-to-agent or A2A escalation, and supply chain corruption. So these are sort of the 4 attacks that I think would be worth your time exploring and really trying to understand how could you actually attack a system in the most likely way. So prompt injection, I'm sure you all might have a sense of what prompt injection is. So when Brian was trying to tell the chat, oh, I'm this person, or ignore this instruction and do this, that's prompt injection. And then sometimes the LLM will just go with it. Tool poisoning, that's where you can basically get harmful outputs manipulating the types of tools connected. So you got to see we were connected to Slack and Jira and a knowledge base. So you can clearly poison those types of tools and what they do. Agent-to-agent escalation, you might be able to trick the LLM to have a tool call another tool, and then that can downstream cause harmful outputs. And that could be a bad response. That could be taking 400 Jira tickets and marking them as done. So there's a lot of these types of problems that can pop up when you know the types of agents in the system.
And if I could just jump in for a second. There's also, so far we've been talking about the agents as not as malicious, okay? But there can be malicious agents. I'm guessing that lots of you heard about a couple weeks ago, Python, they found like 700 packages that had malware in them, and everyone's scrambling to figure out, oh my God, what's going on with this package? And the joke is, well, I would never just install a Python package without doing rigorous checks. Of course, none of us do that. We just say, oh, I need a time zone converter. Oh, there's a Python package. I'll pip it in. Well, that's going to start happening with agents. I mean, if I was truly going to be a bad actor, I would write a small, really, really helpful agent that gave some kind of incredible value, and then in a month or two, did something nefarious. And sometimes they can be fun, sometimes not. I had a friend who worked on an early GPS system. And my friend, my friend made it so that you couldn't get to her sister's house. You drive up and you say, no, recalculating route, recalculating route. And so, it's sort of an innocuous thing. I don't know if the sister thought it was that funny. But you can imagine you can imagine agents that specifically do bad things, and they don't have to do it right away. You wait a couple months. The developer's probably forgotten that they added that agent. They may have moved on to another project, and then the trigger happens, and it starts doing bad stuff. So anyway.
Yeah. And then just the last one was supply chain corruption. So that's where Brian was able to just send a very tiny file up to the knowledge base that was an upsert, and then it got re-indexed. And because of the specific way in which you weaved FinStack AI with all these other types of questions that someone might be able to ask, now the whole context window is going to be flooded with this bad information that was indexed. It was correctly found in the knowledge base, but now it's going to give bad returning results. So let's dive into a little bit about actually what's happening here. So when we have prompt injection here, what actually happens is that you have URLs, PDFs, emails, RAG documents, text, and an example of that could be ignore this instruction. When you send that request to like a curl command, I'm just kind of breaking it up into curl commands and then what's actually happening in the back end. So when you send it as a message, if your AI system is just taking that message as is, that's a vulnerability, because now you're not actually doing any processing or pre-processing. You're, in fact, just taking whatever the user said and running with it, which is highly dangerous, and that's highly dangerous what you were able to do with the chatbot.
And there are places where you won't. Some of the things are easier to defend against than others. Suppose your system can send a message to Slack, just updating, this ticket was closed, whatever. Now suppose your Slack, and so you put in various defenses and protections for your prompts. But then your Slack administrator adds the ability for Slack to make a call out to Jira or something else. You don't know about it. So your attack surface, your vulnerability has just massively increased, and you don't know. I mean, as the chatbot developer, you don't know what the Slack admin in your company is doing. And so there are various ways that you can try to prevent that. Most of these calling tool prompts require special characters. So I think it's like, you say like /Jira or curly brace Jira, whatever. So one of the things you can do is just strip all the special characters. You know, you could even upcase, but just get rid of all the special characters, and that particular kind of attack won't work.
Exactly. So tool poisoning. So you were also able to do that in the chatbot. So the way that it worked was that you were able to trick either API calls or just function calls directly with harmful parameters. So an example of this could be if you were able to send in a prompt, disable user, and you had the actual account that you wanted to disable, what could actually happen is that if you have that in a prompt and you say, basically, I'm an admin and I'm authorized and now do this, that's a vulnerability because the agent tool routing might go with that. And what you really need to think about is what do your tools actually have access to and what are the users, should they be able to call those tools to be able to do those things? For example, like, again, going back to very basic concepts, read versus write. Should Brian be able to have data that reads, or is he able to make basically a put into a bucket or an upsert into the knowledge base or not? Because I don't think you were supposed to be able to have access to that, but you were able to do that. So those are the types of problems that can happen when you have agent tool routing. So this is just, again, a very basic example of what can happen where when you send tools, and also if you think about it, if you are sending a bunch of tools to an agent and basically telling the agent, hey, you can do all these things, it's going to think that it can do all of these things. So you really need to like lock it down and say, OK, you can do this thing, but only if it's this user or only in this specific case or instance. So very basic concepts, but I know like a lot of people are like, oh, let's throw in tools into our AI systems. But you really need to think about like, OK, if I give this agent this tool and it basically has that wildcard star command and it could just do everything, is that what we want? Probably not.
Although in this case, we might be able to use this vulnerability to disable your CEO's email, and so you might get to keep your job.
Keep my job. That would be great. OK, we love that.
OK.
Awesome. OK, cool. So agent-to-agent escalation. So how does this happen? So this is when you are manipulating multi-step chains. So you saw a little bit of that where Brian was able to get a message that was changing something in Jira, and then that also manipulated something in Slack. So that sort of chain of command is something that you want to think about because you can hijack basically a whole workflow, make agents think that they need to do certain things that they really shouldn't do, and then they have maybe higher level escalated privileges that they shouldn't have. Again, if you send an agent, you need to have all these tools, but they shouldn't have all these tools, you're going to have these problems. So that's where basically, and you're sort of going to see this, that you need to have deterministic steps. So this is actually really relevant now, I'm sure in a lot of the sessions that you're seeing, where when you have like a chain of steps, if the agent can decide which step to go through, that's highly dangerous. You always need to make sure that it's deterministic. So when you have like a pre-processing step and a post-processing step, I know you guys understand the concepts of that. But if an agent is able to basically skip a step, it might be, if the prompt said like rush this thing, it might think, oh, I'm going to like eschew these first two steps and go to the last one. So that's where it becomes really important to make sure that you have a multi-step runner that doesn't skip steps. It's deterministic. And if you think about step functions, basically that's kind of becoming popular now because you need to have a state machine. You need to be able to make sure you can process executions and that you won't be skipping around and causing a ruckus like
Right.
Brian did today.
Right, because one of the things is not everything has to be a multi-agent orchestrated system. Not every system is a phone tree where the user could say, cancel my car insurance, subscribe me to Netflix, order me groceries. You know, that's unusual. Most systems really have, specific steps. So a caution is, as much as we love agents, think step functions. I would say, I tend to say, I've drunk the serverless Kool-Aid, so I'm like, okay, lambdas if you can, containers if if you can't, and easy to, sorry, we'll talk. But my advice is think step functions unless you can think of a reason why you shouldn't. And in terms of the workflow hijacking, I also say, back in the day, I worked at a company where there was a compiler for proprietary language, and it was getting incredible benchmark results. And they finally looked at the generated code, and the compiler could tell that the benchmark didn't actually do anything, so it just returned. And it was fast.
There you go. All right. And let's also think a little bit more about that agent-to-agent escalation stuff. So when a user calls a chatbot, Brian called a chatbot, let's say that the user is malicious like Brian. Now, if you call that chatbot and you call Slack, what's really important to think about is that if you've ever set up a chat, actually, who's ever set up a Slack chatbot? Can you raise your hand? I want to see who's worked. Okay. So I'm sure you at some point needed to create a scope or a manifest where you define basically what its privileges are able to do. Now, if you give it access to everything, now you could give access for this agent indirectly to message the debug channel, message the finance team, message the tech lead, look up the C-suite CEO's email and send them a message that my chatbot needs help. All of these things can happen just if you don't think about the scope around, and this isn't particular to Slack, this is particular to any type of system that you integrate, and you can get that RBAC, fine-grained access control, around what it can do. You really need to think about that. And even if you give it all these permissions, but then you tell your agent you can only call, like chat write or chat read, if it still has access to the scope, then it could still possibly be able to then do those other actions. Even if your system prompt, even if the prompt specifically doesn't allow it, it can still happen. So
right, because agents tend to be run in the context of lambdas. And I really hope none of you give star permissions to your lambdas.
Hopefully not.
Yeah.
OK, so supply chain corruption. So this is the last of the many AI attacks, but this is the last one we're going to focus on. So this is when you poison basically all of the information that's in a knowledge base or in metadata or in a database. And that's what you did, where you uploaded a very small file, and it was able to just pollute the entire knowledge base. You weren't able to prompt against it like I was able to. And again, these things can be very easy. You just literally send a document in the prompt, and if that agent is able to do an upsert to the vector DB, well, now you've just basically attached a poisoned document into your flow. And now RAG is vulnerable to be able to then just prompt against all the bad information. So just things to think about where it's not very complicated code, but the idea is very easy to, it's easy to stop if you create patterns to protect it. But again, this isn't like a 50,000 line code attack. This is very simple lines of code that could be very malicious for your AI system. So you just want to think about that when you're working with knowledge bases. Who has access to change it? Can Brian just upload a file, and could my agent think that Brian's trying to update the knowledge base, make a mistake, and then now the whole knowledge base is polluted? So also something that was really interesting was that this specific document did not work very well. It was actually, when you just say return red team rules, there was no chaining. So even though this document got uploaded to the knowledge base, this actually didn't create that attack that you saw earlier. It was this document that made all of those patterns that you got to see. So it's kind of interesting if you basically say FinStack AI, and then you make CEO this, CTO this. If anyone does this, then do this. Basically, that could happen where the way in which it indexes gets chained. And then anytime that someone references FinStack AI, the polluted document or the poisoned document will pop up first. And then it will ignore everything else. Because again, if you say, like you told in the document, basically end this conversation and don't do anything, if it's reading from this document, it's going to be a 1.0 of similarity, and then it's going to say, oh, I should stop talking to this user, and then not get any of the other information that's in the knowledge base. So just some interesting patterns that can happen with that. So when we want to think about end-to-end secure prompt response flow, so obviously Brian was able to just prompt and get a response back. But if you think about it, and yes, before I give you these steps, this is going to add a little bit of latency. But that's why if you message a lot of chatbots for companies, they don't give you an answer very fast. It'll take some time. And what's probably happening is that, of course, Brian, the user, sends a prompt. But then it's going to go through a gateway. And we're going to talk about that in the blue team steps in a second. But it's going to go through a gateway. There's going to be an auth check. Then there's going to be an input security gateway. There's going to be an risk sort of analysis, some sort of classifier, some sort of intent to make sure, what is this user trying to do? Then it's going to have an orchestrator. So that could be sort of your supervisor agent. Just a quick show of hands. Is anyone familiar with the Strands SDK or LangGraph?
Yep.
OK, cool. So you might want to think about that. Like you have an orchestrator agent. But before that gets any tools or information, there's a lot of other processing that's gotten before it actually gets to the orchestrator agent. We'll have a reasoning and inference model loop step. There will be a filter and memory writer, sort of storing information in sort of maybe short-term, long-term. There will be a client response that gets sent back to the user with telemetry. And that's kind of how it all works.
Yep. And one other thing, a study that came out like 4 days ago, and I'll say it's really hard to do slides for a topic that's changing, every 4 days. But some people discovered that if you write a malicious prompt in poetry, it tends to bypass all of the existing security. Because remember, LLMs are really just statistical next token generators, okay? And poetry has a different structure than prose. And so if you're able to write bad instructions in poetry, you can currently break a lot of things. And I posted this in our company's Slack channel, and people came up with a bunch of not suitable for work limericks that actually defeat the system. So don't do that. But at some, and it's funny, my mother is a 92-year-old English teacher, and I said, hey, poetry can break AI. And she's like, well, I told you that. So.
Totally. OK, so you've gotten to see a lot of problems. We've been talking about all these attacks, and you're probably wondering, OK, that's helpful. Basically, I shouldn't build AI. So now we're going to give you the tools so that you can actually secure these types of systems. So these 4 attacks we just walked through, we're going to talk through defense patterns specifically for them. So guardrails, I know you probably have heard about this a lot. Input sanitization, Brian was actually talking about that, of stripping escape characters or special characters. That's more for like prompt injection. Tool poisoning, we need auth, we need parameter validation. IAM enforcement, if you write IAM policies specific to tools or function calls, those are really important. Agent-to-agent escalation, we need deterministic workflows. And then content filters and trust boundaries for supply chain corruption. So we're going to blast through these really, really quick. So when we think about prompt injection, these are the types of defense patterns that you're basically going to want to think about. So the guardrails are very, very pivotal, because before a prompt is going to an LLM, you need to make sure that you catch malicious intent. So Ryan didn't even really message like, I'm trying to hack you, like I'm a bad villain. You didn't say any of that. You literally just asked it for some information.
Right.
Now, is that malicious? Well, it's malicious in the sense that Brian shouldn't have access to that type of information, but he was able to get it. So that's where Bedrock guardrails becomes really important. You can also use NVIDIA NeMo for some sort of guardrails. Meta AI also has ways in which you can use like Llama Guard, and that can do a lot of prompt injection. It's basically LLMs trained on prompt injection strategies, so Meta AI has some good models on that. But also with regex and AST validation, sandbox content, there's a lot of things that you can do to make sure that before an agent ever, or an LLM ever gets a message, that it's being defended. And then tool poisoning. So when we were basically manipulating all the tools earlier in the talk, that's why when you think about like that wildcard, I was giving that example with Slack, if you do not have strict IAM credentials for your tools, that's why when you don't have schema that's validated, let's think about like an agent, right? So if you don't have like a way in which you understand what an agent can do, that's where you're going to run into a lot of problems. So with the Strands SDK, one of the things that's actually really cool is you can create a graph of what Strands is able to have access to. And you can also make sure that you put everything through a gateway. And the gateway is really important because everything's going to go through this gateway. You're going to make sure that they're off, that they have access to the right ability to call the right functions and the right tools, but that people can't just call an agent just because it's in the system. We need to make sure that it goes through that agentic gateway, which is really important. Agent-to-agent escalation. So how do we protect against workflow hijacking? So that's where we're talking about with step functions, deterministic workflows. So we need to make sure that an agent cannot choose the steps. So this is where when you have like a class of step and you're basically defining what can happen, the AI, and this is really important, it's something that Brian and I were talking about a lot, that the LLMs are really good at giving you data, but they should not be making decisions. And they should not be deciding what the flow is. Now you're gonna think like, well, I asked, I don't know, like my different LLMs for advice on certain things. It might create a decision, but it shouldn't be deciding what the steps are in the flow, which is really important.
Right, and I'll say for all of these things, Agent Core is your friend. Bedrock has guardrails, Strands has all kinds of good things, but Agent Core is one of the things that Amazon has done really, really right. Use Agent Core for protection, for runtimes, and
it has tools.
Runtime.
Yeah, exactly. And then supply chain corruption. So that was where we polluted the knowledge base and were able to manipulate the system. So document ingestion, we need to make sure that we throttle who has access to that. And also when you send a file, right? Are we using guard duty malware protection for S3? Are we validating if these files have malicious prompts in there? Not even necessarily a virus, but just bad data, bad information. Bedrock guardrails is a really great way to protect against that. And really just making sure that the content is authentic. So you could hash that. You could also have really strong access control in place to be able to make sure that like people can read, but they can't write. And also the agents that are called can also read but not write. So
let's skip this.
Yeah. I mean,
time.
One of the things that also just you could think about is just with logging. So observability over your LLM system. Another thing.
And I'll say, Agent Core visibility or observability is amazing. And one of the customers that I'm working with, the prompt or the response was taking too long. We used observability. It shows you all the calls that are making, how much time they each took, and the token count. So it's you can write all these things yourself, but use Agent Core. Your life will be much simpler.
Yes. And also, when we want to have containerized RAG with Amazon Bedrock, there's a lot of steps before we even get to the knowledge base. So you think there's authentication, there's a gateway, it's maybe going through your server, doing processing steps, checking a database, before it even checks Bedrock. So this is the thing that we want to instill, is that it's not just enough to prompt and talk to the knowledge base. We really need to make sure that the request is privileged to be able to do that. And then even when we start thinking about creating multi-agent workflows, right? Well, there's a lot of surface area I see now.
Yeah, you're right. Every one of these lines is something I can go after.
Yeah. So you can create sub-agents. Sub-agents are really cool, but you also have to think about that. Of these sub-agents, do they have access to data in S3 that a user could then request access to, trick the agent, and then return that back? So we don't say this to scare you out of making AI systems. It's just you need to think about this, where when you build really complex stuff, there's a lot of a feature sprint and you've got to build a lot of stuff. You really need to think about, okay, if I wanted to get access to this information and I wasn't supposed to get it, can I actually get that information?
Well, I want to scare them.
I know you might, but we don't want them to scare their teams.
Forewarned is forearmed.
Okay, so we were able to completely fix our chatbot. I'm feeling pretty good about the chatbot now, but I understand the changes that we made to make the code more secure and the policies locked down.
Right.
So I feel good about this.
Yes.
You feel good about
this?
this?
Much better.
It is a lot better, but I imagine that things will change in the next couple weeks.
Yep.
Or months.
Yep.
So got to be on our toes here. So this is a production playbook that would be really helpful for anyone that's building AI systems. We didn't talk about this in the talk, but code scanning. There's a lot of great tools from AWS for that. Even using Q Developer, but also file uploads, protections, API protections, logging and observability. There's a lot of really important concepts here that will help you build secure AI systems.
Right.
Or really any system in general.
Right. And if you don't do this, you're taking a real risk. One of my friends recently described agentic tools as the hands for your LLM so that it can do stuff. And hold on the slide for, okay, well, go ahead. So imagine you give this parent is giving the car keys to a hot flash car and a gold card to, we'll call, a young driver, and saying, go buy groceries for the week. Well, this young driver might get bread and milk and cheese and eggs, Or they might say, you know, I like McDonald's, I'm going to bring back 100 Big Macs, and that's the dinner for the week. They might get into a car accident. They might run off with their boyfriend or girlfriend. You don't know. You want to have guardrails. So that's the thing. Just do agents, but do them with caution, understanding you're working with a power tool. And 3, 2, 1, out.
So this is the code. So if you want to check out basically the code from this will walk through the Fast API backend Python server, the Next.js TypeScript front end, which is the chatbot. You'll also see how to create a WebSocket locally with just a runner to be able to liaise between both. And you'll also see a little bit of how we were thinking about some of the attack patterns. There's some good markdown files in there just to give you some context about the code. But thank you so much for coming to our talk and talking about AI security with us.
And please do the survey.
Yes, please do the survey.